Yeah, good morning, students. Welcome to our webinar classes. This is our this is our revision program on physics. So first of all, I would like to thank to our secretary sir and coordinator madam for giving me this opportunity. So now we'll start with the first year physics revision. Here I am going to deal with the first two chapters. As we know from these two chapters, most expected questions, that is very short answers, that is 2 marks questions. Right, so as we know, the first chapter is a physical world, and here from this we can expect a very important question, that what is physics. It is a very important question. It's a basic question, so everyone should learn this. That is what is physics is the first question, so I'm sure that you can get the 2 marks from this chapter. The answer for this is
Swamy sir, మీరు మ్యూట్ లో ఉన్నారు.
మ్యూట్ లో లేను మేడం, నేను మ్యూట్ లో లేను.
వాయిస్ రావట్లేదు, లైవ్ టెలికాస్ట్ కావట్లేదు.
మ్యూట్ లో లేను మేడం, చూడండి ఒకసారి.
జస్ట్ మీరు ఒకసారి మళ్ళీ స్టార్ట్ చేయండి సార్. సార్ ఒకసారి జావేద్ సార్, జావేద్ సార్, ఆర్ యు దేర్? జావేద్ సార్,
ఆయన మ్యూట్ లో ఉన్నాడు.
జావేద్ సార్, కెన్ యూ రెస్పాండ్? స్వామి సార్ మాట్లాడండి.
Yeah, so sorry for the interruption, that will continue the session. See here, we started the revision program on first year physics. Okay, so we'll start with the first 2 chapters now, that is physical world and units and measurements. So now from this chapter, very important question, okay, usually asked from this one is what is physics here. So here it is the branch of science which deals with the study of laws of nature and their results in the different phenomena. See here, for this question 2 marks are compulsory, that to get the 2 marks, your answer should be more elaborate, means more effective. See here, just writing this one is not just enough. If you are adding some examples for this, so definitely you can get full marks. That is, it is just a branch of science that deals with the study of laws of nature. See here, most of you people gets confused. What is this laws of nature? So here I have given some examples here: day and night, eclipse, earthquakes, seasons, planetary system, etc. Just these examples are sufficient. See, if you understood these examples, that you cannot forget the answer. See, here it is what? It is the branch of science that deals with the study of laws of nature. Means these laws are not created by us. See, it is already existing, that just we invented them, just to identify them, that day and night, that we are not created. See, this is naturally occurs. See, this day and night exactly 24 hours. Okay, so it's a systematically happens, and eclipse is also naturally occurs. It's a law of nature. Earthquake is also law of nature. Seasons. Okay, so all these are naturally occurred, that we never created them. So these are, in studying about this thing is nothing but what is physics. See, your answer for this question is, it is the branch of science that deals with the study of laws of nature and their results in the different phenomena. Means at various situations, whatever the experiments, whatever the results we obtain, those are from the basic laws of nature only. That's what the laws of nature and their results of different phenomena. So just write down this sentence, and with some beautiful examples, if you add it in your answer, then no doubt we can get 2 marks for this question. So I am repeating, what is physics? Then the answer for that is what? It is the branch of science that deals with the study of laws of nature. So this should be highlighted, laws of nature. So this is very important, laws of nature and their results in the different phenomena. Okay, so this is one of the important questions from first chapter. And if you move on to the next one, that what are fundamental forces in nature? Of course, it's a very elaborate, means more information is there to learn. Okay, but fortunately, it gives only for a 2 marks question. So answer is only this much only. Means what are fundamental forces? Means you can write those 4. Okay, you can write only those 4. But for more effective and means without any question of deduction of marks. Okay, just like that, if you get total marks, then if we add 1 or 2 marks, 2 points for each force, then it will be very good. Means more effective. I told you that for this question, that is what are fundamental forces in nature, your answer is okay, only these 4 points. Okay, as per the marks point of view, 2 marks question it is. So this answer is okay. But for more effective and more impressive, okay, so without question of reduction any mass, then if we add each 1 point for each force, then it will be very impressive, very good, means become very impressive answer. So there are 4 types of forces are there. So there are 4 fundamental forces in nature. They are, means these are also naturally occur. So these forces also naturally occur. So gravitational force that we never created, electromagnetic force, right? Strong nuclear force, weak nuclear force. So these are the 4 basic, that is fundamental forces. See, I'm repeating, what are fundamental forces in nature? See, this is the second question, second important question from this chapter, physical world. Okay, so this is also most expecting question. So for this, the answer is yes, 4 points only. That is gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Enough. I'm telling you, for more effective explanation, you need to learn a few more points. Means at least 1 point from each force is advisable. Means very good. So just here are some points that gravitational force, just whatever you remember, is whatever the point you remember. So So just I am giving here is only for understanding purpose. But your answer is what? Only for only 4 points. Those are given: gravitational force, electromagnetic force, strong nuclear and weak nuclear forces. And this is only for learning purpose. You see here, gravitational force. It is a mutual force between any two objects. Okay, you can write this point as just 1 point. The gravitational force is a mutual force between any 2 points, that is two objects, and the force is always attractive. So there will be no question of repulsion between the two objects. And it is a long range force, okay, the distance between the two objects, because it's usually used for the huge bodies. And due to this force, both the sun and the earth can able to sustain in the sea. You can write this as an example in that under the title, what's the gravitational force. So I'm repeating for the 2 marks, only those 4 points enough. Okay, for more effective, okay. So if you add just at least 1 point for each force, it looks very good. Okay, so see, we are not giving any chance to deduct the marks to the examiner. The examiner should not take any a chance to deduct the marks, so should not give the chance to them. So here, so this example if you write, so due to this force, both the sun and the earth can able to sustain in their orbits. This is the one of the best examples for the gravitational force. And due to this attractive force between the moon and this one, earth, so that's why this moon is continuous to be rotating in its orbit around the earth. And coming to electromagnetic force, see, all these are only for understanding the concept. You can use any of these points as an examples under the title gravitational force, right? And if you move to the next force, that is electromagnetic force, here electromagnetic force is the motion of charge. See, if you know the electron, it has some charge, and this is moving. While this is moving, it creates electricity. Okay, the charge is moving per unit time, is an electricity. And as long as the electricity is there and the perpendicular to that, the magnetic field is also existing. So that's why they name electromagnetic force. And these forces are stronger than the gravitational force. And see, this, you can write this as an example that, see, when we comb our hair, then comb can attract bit of papers. This is due to the electrical interaction. So that you can write this as an example under this electromagnetic force. Right, so no need to write more, means elaboratively. See, this is not essay question. This is just a very short answer question. Your answer is only those 4 points. And here, for impressive and no question of deduction of any marks, then if you add these 2 points, 1 or 2 points for each, then you will get the full marks. That is what is the question. Okay. Next is the strong nuclear force is there. Strong nuclear force is there. So, and this is also attractive force between the nucleons. Means within the atom, these things happens. So within the range, there exists a strong force and is a short range force, and it is the stronger than the electromagnetic interaction. Stronger than the electromagnetic interaction. So this is a strong nuclear force, and the weak nuclear force, this is also a recent discovery, and this exists only on certain nuclear process such as beta decay. So in this weak nuclear force, the beta decay process takes place, and along with this, it also emits an uncharged particle called neutrino. You can write this as an example. Right, the range of this force is extremely small, and it is neither attractive nor repulsive for both. It is a kind of radiation from radioactivity. Now, if you see this here, after those 4 forces you mentioned, better if you write this green one, that is the strong nuclear force is greater than the electromagnetic force, and weak nuclear force is greater than the gravitational force. If you write this last green one sentence, okay, this is the relation between these 4 forces, then it will be ultimate, means you can get full marks with this last sentence. Means with this says that you have a certain idea on these 4 forces. Instead of writing all these examples, that you mentioned this last point, it will be very impressive. So for a 2 marks point of view, for this question, that is natural forces. Okay, right? So along with these 4 points, if you mention this last relation, then it will be ultimate. Clear? So you means we understood. We try to get knowledge on these 2 questions. Then, if you will move on to the next one. So, which of the following has a symmetry? There's one more important question. One more important question. Okay, from the first chapter. See, first 2 are damn sure, means anyway you have to prepare. Okay, anyway, and of course it is dead easy. So 4 marks right now there in your hand. So move to the third one, that which of the following has a symmetry? Which of the following has a symmetry? Okay, one is acceleration due to gravity, other one is law of gravitation. And if you know the difference between these 2, just if you have an idea on this acceleration due to gravity and the law of gravitation, then it will be very easy to answer. Means easily you can get 2 marks from this. That is, first of all, acceleration due to gravity. Yeah, students, this is related. See, whenever the term, I told you that whenever the term gravity is appear, it is related to Earth only. It is related to Earth only. So, acceleration due to gravity is a sentence related to the Earth only. So, as we know, while we are moving away from the Earth, there is a change in acceleration due to gravity. So this is the basic point that we should understand, acceleration due to gravity. I told you gravity is related to the Earth. So while we are moving away from the Earth, there is a change in G value, acceleration due to gravity. So at various points above the Earth, means at a certain heights, the G value will not be the same. So the answer for this question is acceleration due to gravity is asymmetry because it has different values at different places. Asymmetry, okay, because it has different values at different places. It's not, of course, it is a constant, but constant at a particular range only, or one of the particular regions only. Okay, so this value is not constant for all the places. So that's why it is asymmetric property. So acceleration due to gravity is asymmetry because it has different values at different places. So you can write this. See, you can write simply that means if you are not good at framing the sentence, that just with an example. As we move away from the Earth, G value is not constant. That you know, that is the basic point. As we move away from the Earth, acceleration due to gravity is not same. So this is what asymmetric property. Yeah, you can write like that. Okay, so acceleration due to gravity is asymmetry because it has a different values at different places. Right, now move to the second one, that is the law of gravitation is given. Law of gravitation, this is, see, gravitation. Gravitation is not related to Earth. Here, just the basic difference here, gravity and gravitation. Gravitation is related to any planet. Gravitation may be related to any planet. Right? So law of gravitation is a symmetry because it is same at all the points in the universe. This already we studied in gravitation chapter, and we obtained the relation between small g and capital G value. And in the very beginning of this gravitation chapter, we discussed, means we obtained the expression, the force of attraction between the two bodies, the two planets. We identified that F is equal to capital G into m1 m2 by r square. That was an example, that was an expression that we discussed, that the force of attraction between the two masses. Right, where capital G is constant. Okay, so we're talking about that constant here. This is law of gravitation. See here, that constant value is universally accepted value. So this is not changing at different places because it's a universally accepted constant. So this is a symmetry because it's the same at all points in the universe. So now I hope you understood. See, these two are, one is related to Earth and another one is related to any planet. Okay, so among them, acceleration due to gravity is a symmetry, and the law of gravitation is a acceleration due to gravity is a asymmetric, and this one is a symmetry. Okay, right. So now we'll move to the next one. Is what is the discovery of CV Raman? Okay, what is discovery of CV Raman here? So CV Raman is our Indian scientist discovered the Raman effect in the year 1930. See. From this chapter, one more expecting important question is CV Raman. See, just like that, you can get the 2 marks if you understood the 2 or 3 points on this scientist that just is an Indian scientist discovered this Raman effect in the year 1930. The 1 point you got. The next one, what this Raman effect deals with. This is very important. So it deals with the scattering of light by the molecules of a given medium when they are excited. Okay, so just how this Raman effect is discovered. So this is about light only. It is related to the light only. The molecules of a given medium. See, any medium. The molecules in a particular medium, if they are excited, then what happens? The scattering of molecules, the particles takes place, and he named it as a Raman effect. It was discovered in the 1930. Okay, so what is Raman effect means what? It's a scattering of light by molecules of a particular medium or any given medium when they are excited. Okay, so this is what Raman effect. So you can write 2 points. One is, what is the discovery of CV Raman? The answer for this is CV Raman is an Indian scientist discovered the Raman effect in the year 1930. The first point. And the second point is, what is Raman effect, right? So what is Raman effect means what? It deals with the scattering of light ray by molecules of a particular medium, okay, given medium, when they are excited. Means the molecules are excited in a particular medium, it scatters. And that scattering effect is nothing but Raman effect. Okay. So see, already most of you discussed with your respective faculties. So this is an idea that what points to be mentioned, okay, for getting 2 marks at least, means without any doubt. See, very important points without skipping 2 marks. See, what points to be mentioned for getting full marks, 2 marks. Okay, so if you mention those points, see, you can skip the unnecessary discussions. Just write down whatever the important points to get this one. So that's what I am highlighting this. So 2 points, see, because it's a 2 marks question, right? So these 2 points you should mention over there. That is discovery of CV Raman, right? Now we'll move the Chandrasekhar's limit. That is, what is the contribution of Chandrasekhar to Chandrasekhar to physics? Understood. This is another question. Okay, from this first chapter. So another important question that what are the contributions of S. Chandrasekhar to physics? For this question, the answer is, he is an Indian scientist studied about the structure and evaluation of stars, including sun and black holes. See here. Your idea means your motto to be what? To get the 2 marks, and what exact answer to be given for such questions. You focus on that only. Means unnecessary things, don't waste time for writing such things. See here the important points that you try to remember that. So here S. Chandrasekhar is an Indian scientist studied about the structure and evaluation of stars. Structure and evaluation of stars. And that includes sun and black holes. Right, and any star, if it is at a white dwarf stage, then its mass is equal to 1.4 times of the mass of the sun. Then that has a chance to become a black hole. Now, this mass limit is known as a Chandrasekhar's limit. That is equal to 1.4 times of the mass of the sun. See here to see here for S. Chandrasekhar contributions to this physics, that you write 2 points maximum. That first point is an Indian scientist studied about the structure and evaluation of stars, including sun and black holes. Okay, and this point is At what condition it will become a black hole? Its condition is given. Means here the mass of that any star is equal to 1.4 times of the sun, mass of the sun. Then there is a chance of becoming a black hole. So this is invented, this 1.4 times of mass of the sun. So this limit, 1.4 times of mass of the sun, is the limit, is given as a S. Chandrasekhar's limit. Okay, so here the first point is an Indian scientist studied the structure and the evaluation of stars, including sun and black holes. The first point, and to become a black hole, what is the chance of what mass? What that 1.4 times of the mass of the sun, means any star. It is at the stage of white dwarf. Okay, then a chance of converting into a black hole. So this limit, this measurement, as Chandrasekhar is identified, then so this limit is named as a Chandrasekhar's limit. Just this either of means in these 3 points, if you can write any 2 points, so you can get, because it's a 2 marks question. So focus on these 3 points. Okay, so these are the questions from the first chapter. So without fail, you practice them, and we will move to the second chapter, that is units and measurements. So now here distinguish between the accuracy and precision. Okay, so accuracy is the measure of the closeness of the measured value to the true value. Means whatever we measure some value, if that value is very near to the original value, then it is called accuracy. And if the accuracy is more, then the uncertainty is small. See, if the measured value is very near to the original value, then uncertainty is also very small. Okay, so an accuracy depends on the resolution of instrument and the errors. So accuracy means purely depends on the type of the instrument that we selected. And what is the precision here? Precision is an instrument gives the minimum value that can be measured by it. Means in the precision means depends on the instrument. So what the instrument we selected, so that depends on depends on the type of instrument. Precision means, and more precise instrument may not give accurate value. Okay, so irrelevant devices you selected, then we cannot get the accurate value. And it depends on the least count of the measuring instruments. So that's what in the precision, the selecting type of instrument is very important. And accuracy is what? Accuracy is a measure of closeness. Means whatever the value that you measure, it is if it is very near to that accurate original value, then it is called accuracy. And the precision is depends on the type of the instrument that you selected. Okay, next. And this is only the description is just as an example I have given. This already we discussed in the class that it's in all the faculties that in your class might have discussed with an example. So the routine example only. Okay, and what are the different types of errors? Very important. Without fail, you have to learn that. See here, errors means what? See, however, the very advanced technologies we are using nowadays for the measuring, and still we are getting some difficulties are called errors. And due to various reasons, usually we are unable to get more accurate values. The practical observations, and these errors are basically classified as two errors, that is systematic errors and random errors. And for your answer, see, because it is a 2 marks question, what are the different types of errors? Just there are systematic errors and random errors. We mentioned like that only. So the rest all just I have given only for your understanding purpose, but your answer should be what? There are 2 types of errors. One is systematic error, and another one is random error. And further classification is also discussed here. So systematic errors are again divided into 4, and random errors are these are unexpected, means due to the atmospheric differences like temperature, voltage, fluctuations in nature. So these are the random errors. So your answer is what? What type of errors are there? Means 2 types of errors. So one is systematic error, and the other one is random error. Okay. So Systematic error is just instrumental error, that is device problem, imperfections in techniques and procedures, and means if you are not properly arranged the experimental setup, and environmental conditions means the lighting, the temperature, if they are not supporting to that experiment. And personal errors means where if you are not focusing well, or if we have some eye problems or something. Okay, so that is what personal errors. So comes under systematic errors, and the next one is what random errors. I told you that is only unexpected fluctuations in nature like temperature, voltage, mechanical changes, and experimental setup, etc. Okay, so these are what classification of errors. So for this question, because it's a 2 marks question, so how many errors are there means only 2 types of errors, that is systematic error and random error. If you give more information from here for each point, then it will be very what's that, impressive. Okay, so next we'll move to the next one, the distinguish between fundamental units and derived units. See, is given units. Look at measuring units. They are not asking fundamental quantities and derived quantities. Okay, here these are units. Means for the fundamental quantities, what are the units that we are using? Okay, simple. There are 2 types of units. The basic units, that is fundamental units and derived units. And fundamental units means what? Fundamental units means what? These are units which we measure for the fundamental physical quantities. Okay, so we know that what fundamental quantities that we know, and we are using them, that is meter, kilogram, and second. These are the units. And similarly for the derived units, and the units of the derived physical quantities are called derived units, and these are the derived things that you can anything except these 3 that you can write as an example, that Newton, Joule, Ohm, Tesla, Watt, Hertz, etc. Whatever, any 3 you can write, it will be good. Okay, so this is what is a very most expecting question, that is fundamental units and derived units. Okay, right. Now, why do we have different units for the same physical quantities? So very important. Okay, so why do we have different units for the same physical quantity? Here, for this question, we explained with taking one basic example is length. We have taken here as an example. Okay, we have taken this length as an example here. So this can be explained by an example for the same physical quantity, length. So length is a physical quantity. Interatomic distances are of order angstroms. Okay, interatomic distances are of order of angstroms. See, in a microscopic format, interatomic distances means the distance between any 2 atoms will not be measured. Distance means what is a gap between the 2 things. That is distance between the 2 things. Between Delhi to Hyderabad is what we cannot measure in angstroms, because the distance is very large. But distance is nothing but what length between them. So here the length is a basic physical quantity. Okay, so that we are measuring. Same quantity, distance or length, the same quantity we are measuring at different situations. Delhi to Hyderabad is 1, here atom to atom is 1, and one planet to planet is 1. Okay, so all are what? Distances only, all are what? Lengths only. But we cannot use the same quantity like centimeters, kilometers, light years. See, that we cannot use at all the situations. That situationally we use this units. That's what is the explanation here. Why do we have different units for the same physical quantity? So interatomic distances are of the order of angstroms. Okay, distance between any 2 atoms we measure angstrom, and the intercity distances are measured in kilometers. I told you. So between any 2 cities that we measure with the kilometers. And interstellar distances are of the order of light years. I told you, the planet to planet, a star to planet, or something. So interstellar distances are of the order of light years. So we measure the same physical quantity length at a different, with the different units at a different situations. See, if you are thorough with concept, then you can elaborate this. Okay, we have taken length as in a basic physical quantity, and we have selected three situations. One is atomic distance, another one is intercity distance, and third one is interstellar distance. Okay, so for these three situations, we are measuring distance only, but at three different places, we are using different units. One is angstrom, another one is kilometer, the third one is light years. Okay, I hope you understood this, right? This is also most expected question. And now we move to the what is dimensional analysis. Dimensional analysis. Usually this question will be asked in 4 marks, okay, but sometimes this may ask in 2 marks also, only for just what is the dimensional analysis. Of course, the 4 marks is very important, and you should understand, you should know this one. So first one, dimensions. Okay, so what is the dimension? Dimension. See, here definition is given. The dimensions of physical quantities are, dimensions of physical quantities are, dimensions of physical quantities are the powers. Dimensions of physical quantities are the powers, that's exponents, to which the fundamental quantities base or rise to represent that physical quantities. I am repeating, the dimensions of the physical quantities. Physical quantities means any physical quantity, but we are representing that the powers of the fundamental quantities. What are the fundamental quantities? Mass, length, and time. These are the fundamental physical quantities, right? So here the definition is, the dimensions of physical quantities are the powers to which the fundamental quantities. Fundamental quantities, I told you that the basic fundamental quantities, that is mass, length, and time. So these are the basic. Now, whatever the physical quantity we need to describe, then using these basic fundamental quantities only we can elaborate. And especially the powers on it, the power exponents of this basic fundamental quantities gives some interpretation of any kind of physical quantity based from this basic, that is fundamental quantities. Now, dimensional formulae can be used to convert one system of units into another system. Means it is the advantage. What is the use of this dimensional analysis? That easily we can convert one system of unit to the another system of unit using dimensional formula. And we can be used to check the correctness of the equation, whether see experimentally, if you are doing some calculation to conversion of any system of units, then here also how correct means whether the approach is correct or not, that we can check with this dimension. Now, using to obtain the relation among the different physical quantities, yes. So here also conversion, we are converting system of units. Here also how many times both the relation between the system of units also we can obtain. Okay, we can obtain the relation among the different physical quantities in how many times. Say 1 kg is equal to 1 kg SI unit, it will be converted into CGS, then how many times it will be. Okay, 1 centimeter if you are converting into SI unit, then how it will be. CGS, SI unit, how means how many times, that gives the relation among the different physical quantities. And we can find the physical quantity, unit of physical quantity. If you don't know, for example, if you doesn't know what is the physical quantity and what is the unit for that, then using this dimension also we can estimate, we can calculate the unity. And for this different types of quantities are given for just for understanding only. Okay, so this is just for understanding. Right, and for 2 marks question, so no need to write all the things. Just you can select, you can write to either 1 or 2 as an examples with that explanation. Okay, so what is the dimensional analysis is the question. For that, just whatever that we discussed just now, this analysis, this discussion is enough. And along with that, if you write any 1 or 2 dimensional quantities explanation for this is well and good. Okay, so select any of these things, that is physical quantities like area, volume, density, speed, acceleration due to gravity. So all these are the physical quantities, and here this bracketed one, for example, area. If you are taking area, you should know that definition, that is length and breadth. Okay, product of length and breadth is an area, and length and breadth both are what? Length related only, distance only, that is meter. Okay, so m0 means in this mass is not there, time is not there, only length is there. Means only length is a physical quantity is there. So length into length. So it's a length square. So L power 2. So power 2 indicates that physical quantity, length, and m square is the unit. So this is what how we can relate the physical quantities with the units and the powers. Okay, so this is what is the dimensional analysis. Now, some of the important problems also will be asked from this chapter, most expected problems. Right, and here see the velocity. It's a repeated problem. It's already most of you known with this. Okay, so here we'll see just the velocity of the body is given by v is equal to. It's a problem. It's repeatedly asked, and it's one of the best problems. Okay, so the velocity of the body is given by. See, for a particular body, the velocity is given as an equation v is equal to at square plus bt plus c. If v and t are expressed in SI unit, so with this we can understand that v is a velocity is given and the t is given time. So both the velocity SI unit is meter per second and time is a second. So both are expressed in SI unit is given, and what are the units of A, B and C thereafter. Okay, so here what information is given? One expression is given. In this velocity, it's a purely saying that it's a velocity. The body is moving with a certain velocity, right? So velocity we understood, t that we understood, and what is asking? What are the units of A, B, C? So A, B, C, we don't know what physical quantities they are, right? And they're asking to identify the units for them. So here, according to principle of homogeneity, means, look at this equation, v is equal to at square plus bt plus c. At square plus bt plus c. Simple logic here, velocity is equal to this whole component, right? Just logic. Velocity is equal to whatever the right side is. Whatever the right hand side is, some component is there which is equal to the left hand side. That is what? Velocity. So what you understood that left side is velocity which is equal to right side component. So both are velocities only, because we are studying as per the principle of homogeneity. So velocity is equal to this component, means at square is related to velocity, bt is related to velocity, c is also related to velocity. Understood? So at square is a velocity component, bt is a velocity component, c is velocity component as per the principle of homogeneity. That's what is given here. See, v is equal to at square, right? Similarly, at square, similarly, bt, similarly, c, means this equation just we framed as per the homogeneity equation. V is equal to at square, that is equal to bt, that is equal to c. So now taking first this relation, v is equal to at square relation. First we are selecting this relation, v is equal to at square. Then what is velocity? Velocity is the meter velocity. Definition, meter per second. That is distance by time. Okay, velocity is equal to displacement by time. So meter by second unit. That's what is dimensional and all. The dimensional quantity for this one velocity is length time inverse L p power minus 1. That is meter per second. Meter per second. That is equal to a t square. A t square t already is given in the problem. It's an SI unit. that is type t square. Then from this, take out a value. Take out a value. So this is an equation. V is equal to a t square. V is equal to a t square. Understood? So both the equation, left side and right side, both are in dimensional formula. Okay, so now taking out this a value out, then LT by t square, and by t square will move upward, it will be minus 2. So minus minus plus, so it will be minus 3. So what else remain? LT power minus 3 is remain. So this is what is the unit of A. Okay, A is a constant. So unit of A is meter. L is what? Length. Meter. Time is what? Second. So S power minus 3. So meter per second cube is the unit for A. So similarly, we do the same step. Similarly, V is equal to BT. V is equal to BT. Right? V is equal to BT. See this example. V is equal to BT now. So V is equal to BT. Here comma should be there. So velocity. Now again we are converting this equation into dimensional formula. That is velocity. That is meter per second. Here is that meter per second is equal to BT. Okay, B. Small b became what? The time is given in the problem. That is because the time is given in the SI unit. So time. So again, L t power minus 1 is equal to B into T, then T take out B, then L t power minus 1 whole by T. Then T will take out, take upside, then it will be minus T. So minus of minus plus 2. So L t power minus 2. So B is equal to L t power minus 2 you are getting. So unit for this one is L, means meter, time is per second square, that is meter per second square. So this is B, unit is meter per second square. And similarly we do the same, velocity is equal to C. So if both are same means what? Whatever the velocity is left side and right side is also the same quantity, that is both are same. So automatically the C will become what? L t power minus 1, because velocity has L. What's it? Velocity is L t power minus 1 and C also L power t minus 1. So here like this, using the principle of homogeneity, we can calculate, we can estimate the constants, means units for the constants that we have solved using homogeneity expression. So just understand, using this relation, just we equated individually V is equal to A square, V is equal to BT, V is equal to C, and from that taken out B values. Okay, so practice them. Then we move to the next one. It's very important that a physical quantity X is related to 4 measurable quantities. Next important, very important problem. A physical quantity X is related to 4 measurable quantities A, B, C and D as follows. Okay, there is a physical quantity. There is a physical quantity X which is related to 4 measurable quantities. Okay, X is given in terms of 4 measurable quantities. Look at this equation. X is equal to X means any physical quantity which is expressed in terms of like A, B, C. There is A power 2, B power 3, C power 5 by 2 and D power minus 2. The percentage error in the measurement of A, B, C, D are percentage error. What you understood with this? Here, while we are doing experiment on any physical quantity X, for example, a final experiment value having some error, those errors are like this. I'm repeating, while we are doing any experiment, for example, we are measuring the length of the book. Okay, while we are doing, you got some value, maybe that value may not be correct, may not be exact value to the original, means true value. So there may be some issues, there may be lots of issues that we discuss, symmetrical, systematic errors and random errors that we discuss. Okay, due to so many errors, we didn't got accurate value. So some errors are there. Some how much error is given, some percentage of error is given. Okay, to the original, to the obtain, how much percentage error that we got is given in the problem. A is a physical quantity, is measurable quantity, has 1%. B is a 2%, C is 3%, and D is a 4% respectively. Now, what is the percentage of error in X? What is the percentage of error in X? So, here, because of the ABCD got different percentage errors, then what could be the total percentage error of this physical quantity X is asking. What is asking? X is a physical quantity in which 4 variables are there. 4 are getting some different percentage errors. Then what would be the total percentage error of the physical quantity X they are asking? The simple. Okay, so look at this question. This is the expression X is equal to a power 2, b power 3, c power 5 by 2, and b power minus 2. This is an expression is given, and see, we have learned percentage error expression like this: changing a by original a, changing a by original a, okay, into 100. That is percentage. How much is given in the problem? 1%. Similarly, changing b by original b means originally b has some value, but after doing the experiment we got some change. So that ratio is what is the percentage error is given in the problem 2%, and delta c by c is a 3%, and delta d by d is a 4%. The values are given here. Now, so percentage error. So with the help of this information, what we are calculating now, percentage error in the total physical quantity, that is X. So just we are rewriting this expression. So what is our title here? What's that? Percentage error in X. So how we can get this? Change in X by original X. Change in X by original X into 100 means percentage. This value we need to calculate. Okay, this value we need to calculate. So for that, what we are doing? See, a power 2. So 2 is taking forward here. Okay, coming in front of this, and a value, a is this one only, change in a by a into 100. Okay, so this whole step we have means instead of a, this we are rewriting. This bracketed one is a value. So a value is given in the problem 1%. Similarly, this is b is given 2%. Like that, wherever a, b, c, d are there, we are writing this in a percentage format like this, bracketed ones. So 2 is a 2 is coming forward here. So this one plus 3 into b plus 5 by 2 into this one plus 2 come forward into this bracket. So and this changing a by a values are already given in the problem, that 1%, 2%, 3%, 4%, wherever this term delta d by d is there, you can use 4%, delta c by c is there, you can use 3% like that. So we are substituting all the values. So this value is as it is, delta x by x into 100 is equal to 2 into, what is this bracket value is given? 1%, this is 2 into 1 plus 3 into delta d by d is how much? 2%. 3 into 2 plus 5 by 2 into, what is this? Delta c by c into 100 is a 3. So 5 by 2 into c plus 2, this 2 into delta d by d is 4%. So simplify this whole expression, then we can get approximately 23.5%. So this is the percentage error of this physical quantity X when A, B, C, D are different errors like this. So this is the way to solve. This is also one of the important problems that come across, which we are most expecting. Right, and now we move to the next one. Very, very, very important. State the number of significant figures in the following. Actually, this problem may come for 4 marks, but you should be aware. And sometimes the problem's point of view, this is also the most expecting question. And to solve this question, you need to learn some points. You need to learn some points that significant figures that already we learned. I mean, some points, if you understood, then any kind of figure that we can estimate. That is most important. So to understand, to solve such questions, you need to understand these points. So it tells about the number of digits in a measured value that we are confined on. So more is the significant figures, more is the accurate measurement. Okay, so here are the rules for identifying the significant figures. So all non-zero digits are significant, all non-zero digits are significant. These are the rules only for understanding. Okay, like that, so many rules are there, and these are the basic rules. Okay, so all non-zero digits, non-zero, whatever the figure is a non-zero, then it will be a significant. And zero between two non-zero digits are significant. Means zero between any two non-zero digits, it will become significant. And zero between two significant, okay, zero between any two significant is also significant. And initial zeros are not significant. The number it is started with a zero, then it is not a significant. And the final zeros are significant if after decimal it is there. After decimal, means it's a last digit. Okay, final zeros are significant if it is after decimal. Okay, after decimal, if it is in a zero is there, then it will be a significant. Next up, order of magnitude is not significant. Order means some 10 power something. Okay, so those are there, no? So that is not a significant. And all the constants are significant. Now, if we see the previous one, the state the number of significant figures in the following. So, as per the rules that we discussed, so then we can proceed to solve such questions. That here 6, 7, 2, 9 is all are significant. There is no zeros. There is non-zero. Okay, non-zero figures. Non-zero figures are significant. So, 6, 7, 2, 4 contains 4 significant. Means all are significant figures. Next, 0.024 contains only 2 significant figures, because after decimal and before there is no significant figures. So only 2 are there, that is 2 and 4 only. And the same rule follows for the C point is also, yeah, see here 4 only. Okay, so here decimal, right? So then only 8 to 40. And this 0 is after decimal and after significant. So that's why this 0 is also significant. Then 4, that is 8 to 40, only 4 significant figures are there. So if you know the rules, then you can write the significant figures. This kind of question that you can easily attempt. And 6.032 contains 4 significant. I told you after decimal the digit is what? Means before decimal it's a significant, and after that decimal 0 is there, it is also significant. Then it contains 4 significant figures, and here 4.57 into 10 power 8 contains 3 significant figures. So just now we discussed the power orders are non-significant. Okay, orders are non-significant. Here see, order of magnitude is not significant, 6 point. So that's why what's that? 4.57 into 10 power 8. So the orders will be eliminated, means this is not significant. So only 4.57 are there. So only these are significant. So such questions that you can answer easily if you understood the 4 points, right? So here are these are the important points, important questions that mostly we're expecting. So practice all these questions as short as possible, and if your answer should be more effective, then try to add more points that whatever we discuss, because all these are only means from these 2 chapters only 2 marks questions that you're expecting, and it is a easy, very easy, and very limited questions are there. You try to get more marks. Okay, so all the very best for the examinations, try to score more. Okay, thank you all.